Okay, today is October 26th, 2021. This is section 6.2 in your grade 8 Math Links book on dividing fractions by whole numbers. We're going to start here at question 4. That gives you 4 questions, each asking you to determine each quotient. And of course, what does this word mean? It means the answer to a division. So far, now you know all 4. You know product is the answer to multiplication. Quotient is the answer to division. Sum is the answer to addition. And difference is the answer to subtraction. So we're going to start with A. It says a quarter divided by 2. So the first thing you need to do is just draw a quarter. And the easiest way to do that is cut it in half, a rectangle, and then cut each of those parts in half, and then shade in one part out of the 4, right? And that is a quarter. And when we divide it by 2, what we've been doing in our modeling is we've been actually considering this to be a chocolate bar. So we have 25% of a chocolate bar, or a quarter of a chocolate bar, divided between 2 people. So this is going to be divided between Calvin, who's not here, and myself. We're going to share this quarter of a chocolate bar. Here he is now, speak of the devil. So once we divide that between each other, the question I wanted to ask you is, what was our denominator when we started here in this picture? What was our denominator? 4. And when I made that cut, what did our denominator become? 8. So we know that our answer is going to be 8 out of 8. Our denominator is going to be 8. How many parts do I get out of those 8 parts? 1. So when we say a quarter divided between 2 people, it is 1/8. And if you wanted to check your answer, since we know a quarter is actually 25%, this same question, not using fractions but using percentages, would be 25% divided by 2. Does anyone know, without me grabbing a calculator, what 25 divided by 2 is? 12.5. So if I was thinking percentages here, and you don't have to, but I asked you to try and add that to it because it helps you understand what it's all about. If I said, what is 12.5% as a fraction, it should be 1/8, correct? Since they're the same thing. So if I take my calculator and go, what is 1 divided by 8? It should be 0.125, right? And it is. So it's 12.5%. Your second question says 1/3, so B, 1/3 divided by 3. So again, we're going to start with our rectangle of chocolate. We're going to shade in a third. And if I divide that between 3 people, here I'm going to divide it between myself. I'm going to divide it between Olivia, and I'll divide it between Alexis. Whoa. If I ask myself the question, or ask you guys the question, what was my denominator? It was 3. When I made the cuts into 3 parts this way, what did my denominator become? It became 9. So my answer is going to have a denominator of 9. And how much does each of us get to have of those 9 parts? We each get to have 1/9. So a third cut into 3 parts is 1/9. If I think of it as percentages, what is 33%, or 33.3% actually? It's 1/3 is 33.3 repeating percent divided between 3 people. Can anyone do that math in their head of 33.3%? 11.1% repeating, correct? So we'd say that's 11.1% repeating is my answer. So again, just like before, 1/9 as a decimal should be 0.11111, right? So if we take it with a calculator and say, what is 1 divided by 9? It is indeed 11.1 repeating percent, okay? So that's just a way to kind of get, most of us understand this part. We understand that we had 33.33% of a chocolate bar. Divided between 3 people is 11.1%. That same idea, it's the exact same thinking. The only difference is, instead of using percentages, we're using fractions, right? But it's that correlation between a fraction and a percent are the same thing that's important. Question C gives us 1/5 divided by 2. Or if I drew it, 1/5 would be 4 lines, make 5 parts. Shade in 1/5. So that is 1/5 of a chocolate bar. Divided between 2 people. Here I'm going to share it between Dominic and Lucas are going to share this chocolate bar. So before my denominator was 5, once I made my cut, my denominator became 10 parts. There are 10 parts here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And since Dominic is getting this part, how many parts of the 10 does Dominic get to eat? 1. So your answer is 1/10. Without grabbing a calculator, does anyone know what 1/5, the fraction 1/5 is as a percentage? 20%. So if I say 20% divided between two people, each person gets 10%. Does that make sense with our answer? Yeah, it does. 1/10 is 10%. And our final question, 5/6 divided between 4. I'll draw my 5/6. If you're drawing sixths, the easiest way is to cut your rectangle in half and then put two equally spaced lines there and two equally spaced lines there, and you have 6 parts. Shade in your 5. And as I said once or twice in my life, Bob's your uncle. Once we have 5/6, we're going to divide that between 4 people. So I'm going to divide it into 4 parts. And I'm going to share it between, who's here that I got? I got Olivia again. Let's see if I can do it without looking. I got Dominic. I got me. Why not Calvin? I'll just give it to Calvin. He's in my head. So those 4 people are sharing in 5/6 of a chocolate bar. My denominator was 6 before I made the cuts, and after I made the cuts, I have 1, 2, 3, 4, 5, 6. 6, 6, and 6 is 24. I have 24 parts. How much does each of us get? 5/24. Convert that to a decimal, or percentage, excuse me. I don't know what 5/6 is, so I'm going to go, what is 5 divided by 6 as a decimal? What's that as a percentage? 83.3%. So 83.3 repeating percent of a chocolate bar divided between 4 people. So if I take my calculator again and say, take that and divide it between 4 people, each person receives 20.83 repeating percent. 20.83 repeating percent. What should equal 20.83 repeating percent? 5 divided by 24. If I change this fraction to a percentage, it should be 20.83%. And it is. So we do have equivalency with that. Question number 6. We're going to skip 5 and go right on to 6. It says there are 2 different South Indian fish curries called dopa and mole. Both include coconut. Dopa requires half a coconut to make 2 servings. What fraction of a coconut is in each serving? So what we're going to try and do is we're going to try and contextualize or put into context with a picture what this means. So I'm going to draw a coconut, and guess what shape I'm going to use? That's right. I'm going to make a rectangle to represent my coconut. Now, if you really want to, you can make a coconut however you want, but it works well because when I divide this between 2 servings, it's going to become apparent how much is in each serving. So I'm going to cut it in half, and this is going to be serving number 1 and serving number 2. According to my picture, what fraction of a coconut is in each of those servings? A quarter, right? So serving 1, that's the amount of coconut in serving 1. And how much of a coconut is it? It's a quarter of a coconut. So therefore, a quarter of a coconut is needed to make 1 serving of dopa curry. Mole, it still requires a half a coconut to make the recipe. Yes. So there's our half a coconut. I don't know why it's yellow, but it is. But that half a coconut makes 4 servings, which is different than the dopa curry. So I'm going to cut this into 4 parts. Serving 1, serving 2, serving 3, and serving 4. That's how much coconut is in each serving. And how much is that in terms of a fraction of a coconut? That is 1/8, right? 1/8 of a coconut is in each serving of mole curry. Our next question, 7, says a pitcher of orange juice is 2/3 full. Oh, let's draw a pitcher of orange juice. What shape should I use? I think I'll use a rectangle. And I will make it 2/3 full. And this time, the good news is I actually have the ability to use orange. So we're not only going to fill it with orange juice, but we're going to fill it with orange juice. The only problem is I should have made the rectangle black, so I'll go over and trace it again. Yeah, you know what? You're right. This looks more like Tang, but we'll pretend it's right. So this is your pitcher of orange juice, which is 2/3 full. If 4 students equally share this juice, all right, let's equally share. So I'm going to cut it between 4 students. Student number 1, student 2, student 3, and student 4. What fraction of a full pitcher does each student get? So let's just think of it. What was the denominator here? What was the denominator though? 3. What's the denominator now? 12. How many parts of the 12 does each student get? So the answer is each student will receive 2/12, which if you left it like that, that would be fine. However, you probably should all acknowledge that that is not lowest terms. We can reduce that to lowest terms, which says 1/6. So each student will receive 1/6 of a pitcher. Let's just make sure this is right. Does anyone know what percent of a full pitcher that is? 66.6 repeating percent, correct? That's how much 2/3 of a pitcher. So we had that percent of a pitcher divided between 4 students. If I check my work, 66.6, oh, that's not right, clear. 66.6 repeating percent divided between 4 students means that each person will receive 16.6 repeating percent of the pitcher. If that's true, then 1/6 should be that same number, right? 1/6 is 16.6%. Any questions so far? We're all good? All right, let's go on to the next one. Oh, this was a fun one. The areas of Alberta, Saskatchewan, and Manitoba are... Did I do this with you guys yesterday? I didn't. Okay. So I'm going to draw Canada. A really, really poor version of Canada. Let's see if I can do... I did, didn't I? That's not terrible. PEI's here. Newfoundland's over here. That's actually not bad. That's one of my better Canadas that I've ever drawn. What's this right here? What's this here? Hudson Bay. You guys know your geography. Fantastic. So I'm going to cut it down here somewhere. This is BC. And in here, this is Alberta, this is Saskatchewan, and this is Manitoba. Okay, ASM. Great Lake, you're kind of right there. We got Lake Toronto's right there. It's not bad at all. So this part of Canada, it says accounts for roughly 1/5 of the total area of Canada. So this area here in red is 1/5 or 20% of all of Canada's area. Okay, so if you don't think about fractions, we think about percentages. That makes sense. That is 20% of the entire area. And each of these 3 provinces, Alberta, Saskatchewan, and Manitoba, are roughly the same size. Okay? So if I wanted to know what percentage each of those provinces makes up for Canada, I would say since those 3 are 20% of Canada, divided between the 3 provinces, I can take my calculator and go, well, 20% divided between 3 provinces means that each of those provinces is roughly 6.6% of all of Canada, each of them. That Alberta 6.6, this is 6.6, and this is 6.6, roughly. Okay? But we're not allowed to use percentages. We have to use fractions. So that same question of 20% divided by 3 can be rewritten as 1/5 of Canada's area divided between the 3 provinces. Okay? So we're going to take this and say, well, this is Canada, our standard chocolate bar. And we're going to say that Canada, that little blue line represents the area of Alberta, Saskatchewan, and Manitoba. So that 1/5 of Canada is represented with that blue little spacer. That's all of Alberta, Saskatchewan, and Manitoba. If I divide that between 3, I'm going to divide it this way. I'm going to say this is Alberta, this is Manitoba, this is Saskatchewan. What fraction of Canada's area is this one here? 1/15. Do you agree? 1/15. So 1/15 should roughly be 6.6%. So we'll just double check our work here. Take my calculator. 1 divided by 15 is 6.6 repeating percent. So we are right. 1/15. Each of these provinces is 1/15 the total area of Canada. Our next question, question 10, we're going to do, it says Mark uses 1/3 a tank of gasoline in a 5-day work week. So we're going to draw Mark's gas tank. Oh, it's a rectangle. Everything is rectangles in my world. And this is how much gas of his gas tank Mark uses for a 5-day work week, driving to work and back from work. So on Monday, this is Mark's house. This is Mark's work. Mark drives to work and then he drives back. That's on Monday. Tuesday, Wednesday, Thursday, and Friday. How many trips does Mark take to and from work? 10 trips. Do you agree? So this 1/3 of a tank of gas we'll do 10 trips, once to work and once back during the 5 weeks. So it's actually 10. So if I write that, it's going to be 1/3 of a tank divided between 10 days is what this is going to have to represent. It's going to be difficult to draw, but we'll try our best. Cut it in half, put 4 lines in here. 4 lines in here. That's not bad. That's 10 parts. So this is Monday morning, Monday AM, Monday PM, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday. The denominator was what before I cut it? 3. What is it now? There are 30 parts. Oops, 30 parts. How many does it take to go to work? 1/30th. Does that make sense? Does anyone want to guess what 1/30th is? Now, I'm not going to write anything down. What is 1/30th as a percent? If you can use your brains for just a second. Everyone wire themselves in without writing it down. The answer, of course, is because this is 33.3%. When I divide that by 10, I simply have to move my decimal one place over. So my answer would be 3.3 repeating percent. And if I use my calculator, which I just did, but I'll do it again, 1 divided by 30 should be 0.03 repeating, and it is. Okay. And I think the second last question we're going to correct. It says Iqaluit has frost for about 3/4 of the day in a year. I wonder what we can do to draw that. Let's use a rectangle. Let's use a rectangle and cut it into 3/4. This is Iqaluit's frosty days in a year. That's a lot of frost. It has frost on 5 times as many days as Vancouver. Wow. Oh, thank God Deacon was here. So this represents Iqaluit, which has a lot of frost days. But Vancouver has, or Iqaluit has 5 times as many as Vancouver. Or another way to think about that is Vancouver has 1/5 as much as Iqaluit. So if Vancouver has 1/5, then I'm going to divide this into 5 parts. 1, 2, 3, 4. And this is going to be Vancouver, right? That's going to be representing Vancouver. So if Vancouver has 3/4 of a year, Vancouver is going to have that, which is now going to be, the denominator was 4, it's now 20. And therefore the fraction of days of a year is 3/20. Now, I'm going to ask you a very important question. Does anyone know how many days that is? All right, 3/4, that's 3/20 of a year, right? 3/20 of a year. Does everyone agree? That's Vancouver frost days. What does of mean in mathematics? And how many days in a year? All right, let's go back to our 6.1 learning. If you have 3/20, imagine what that is, and you multiply it, that picture of 3/20 by 365, how many 20ths would you have? You would take 3 and multiply it by 365. 365 times 3. You would have 1,095 20ths. Which if I divide that 1,095 by 20, this is getting more confusing than I anticipated. That means that during a year, 54 3/4 days of a year in Vancouver is roughly, approximately 51 days a year. Roughly 2 months has frost. All right, that didn't go as well as I anticipated, but that's okay. Let's go to the last question. It says, it takes 4/5 of a roll of ribbon to wrap 6 packages. This is much easier. Let's draw a roll of ribbon. 4/5. You know what? Just because it's ribbon, and ribbon reminds me of pink, I'm going to make the ribbon pink. Okay, so there's our ribbon. Interesting. Wow. It's going to make 5 packages. So cut it into 6 packages. Sorry, 1, 2, 3, 4, 5. To make 3 packages, it takes 4/5 to wrap 6 packages. There is 3 packages. Did I do that right? I didn't do that right. I should think before I start drawing. All right, let's try this again. So 4/5 makes 6 packages. So if I want to make 3 packages, how much of that 4/5 do I need? Half as much or twice as much or 3 times as much? If this makes 6, how much of that does it take to make 3? Half as much. How do I make half using division? Divide by 2. So there's our question. 4/5 divided by the 2, right there. What fraction of a package is required to make 3 packages? 4/10. Let's think of it in terms of percentages. It takes 80%. It takes 80% to make 6 packages. If I divide that by 2, it takes 40% to wrap 3 packages. Bob's your uncle.